Okay, so last time, in the last episode, we implemented strings. That was good, but we didn't implement ownership of those strings. And that feels like we kind of left something hanging there. So we're going to add not only ownership, but the ability to specify that a type is not sized so that it needs ownership and other things like that. So let's just start with specifying the type size. So I know that this is in var pre. This is how we parse our variables. So just to look at a little bit of fungi here, which we don't have very much yet, but we're getting there. This is a variable in the get method. It has a name, and that's what var pre does. It gets the key, scan, dedupe, C string. It scans it and it also tries to dedupe it, so we're not using extra memory. And then it requires this colon, creating a type for it first, to make sure we have enough room for it, scanning the colon, and then calls scan type I. Now scan type I has, it returns the type, which it gets looked up in the dictionary. So in this case, it will return and slice UI. It'll look up slice UI in the dictionary, and it will scan the and, which is part of the type spec. So the and is part of the type spec. The type, the refs, and the array length are what's interesting in the type spec. And what we're going to do here is we're just going to add an else if you put a question mark anywhere in your type spec. Sorry, it'll reload apparently. If you put a question mark anywhere in your type spec, then we're going to if you put a question mark anywhere in your type spec, we are going to set array length equal to unknown tie unsized. That's what it is. So, and then we're going to do assert not s.array length cannot have use not so the correct syntax for the array is that. So let's just make sure somebody doesn't accidentally use a question mark with an array syntax. Because the correct array syntax is the number of elements followed by the type. Like this. Something like that. That's in a U4 array of 4 elements. Oh, and I think let's make this a little bigger for everyone. Okay, so that's all looking pretty good. So that allows us to specify that some pointer that we have is an unsized type. I'm going to put this first, just to kind of say that the typical use of this is that you do question mark and then an and. To say that I'm pointing at this type, but this type, there might be more than one element of this type. It's an array. Great. And that should work. Let's just test that real quick. There's not much testing here needed, but what are we? Simple array. Yeah, this is the array test. Let's just define a function and see if it even compiles. I'm not Um, it's not going to actually do anything. All it does is it uses this new type syntax that we have. Oh, that didn't like that. Oh, these are separate tokens. Right. There we go. That's interesting. I would not expected and to be a token. And should be its own token. What is that? Single? Pilot. It'd be in scan. Scan raw. What does this look for? 2 token group. All right. I don't have and in here. That needs to be its own token. So now I should be able to do this. Great. Okay, so yeah, so that's the basic syntax. And I guess I could pull this. What would this be? Tie unknown equals current find, I think it is. Yeah, current find type. Okay. Use let's just call this unknown. And then this is going to be a tie function, sorry. So that should be fine. Okay. And then what does this look like? It has inputs. So the tie var x equals unknown inputs. This is the tie function. It has an input tie I, and tie I has a metadata, and that metadata uses this constant tie I unsized. So meta so we can just do assert equal we'll just do assert to say that the input metadata has tie I unsized on it. Okay, that's all working. Good. It's always good to check that you're actually running it. Sometimes I like to do that, and yes, that failed. So good. Especially when things just work. It's always amazing when that happens. So now we have a way to specify that our pointer type is actually kind of an array. It's a pointer to an array, which is going to be important for us. So just to pull up our bug, I made a few edits to it just recently. Basically, my conclusion is We're not going to be able to do a generalized ownership tracking system. I talk about that up here. It's quite a lot of details that maybe are not that interesting. So instead of a general solution, we're going to make a specialized solution where if your type has a dynamic array attached to it, where you track the length, or if your type points to some data where you track the length of that data, then guess what? You can implement declare ownership and return this ownership object, which is simply a singly linked list of other ownership objects. It's the metadata, which we won't probably use at all in v1, but I wanted to make sure it's there. The offset, aka the field that has this ownership, and the length. The current design is if the field is an array. Maybe I'll just put this in the metadata actually, but we can talk about some of the details here shortly. I like to kind of have a general idea of what I'm going for, but not a perfect design yet, and we can always change it later if we need to. So one of the first things here, this is our current var, and I'm currently using this. Kind of overloaded it in a previous, not a recorded episode, but I'm kind of overloading var for aliases and for structs. What did I do? I can't remember actually. Sorry, I'm having trouble remembering what I did here. Compile var, compile type, var pre. Here, I'm going to pause the recording here while I try and figure this out. Okay, I remember now. It was the super here. So in TIDEC find, I used the super. And the super is the tyvar. I'm actually fine with that. I forgot how this worked. Basically, when you define a structure, you can define the first field as super, and if you do, then the it's basically single inheritance, single data inheritance, I call it. And that was fine. I'm not worried about that. But what we're doing here is we're having ownership. So just to go a little bit into Spore. The Spore compiler is a bytecode compiler and basically just loops over these instructions, which can be things like duplicate what's on the stack, increment what's on the stack, add two things that are on the stack together to push something on the stack, etc. And most of these are, fairly benign. You can call things, call a function that's on the stack, call literal, things like that. Now things got a little tricky because I wanted to have information available if you're accessing a global. Excuse me. So if you're accessing a global, Spore globals fetch GL, that's what it is. I have an op 42, meaning a 4 byte followed by a 2 byte, and it's really the global the pointer to the global and then the global's offset. Now for something like this string that we just implemented, that's kind of like a global as well. The whole point of this is to, so let's just take a look at fetch.gl here. I've got a lot of stuff here. Yeah. So this pops the reference to the global variable, which is a type variable. And I straight up cast it here. And then it gets right, the V is the location of the data plus the offset here. And it fetches size I from that. So any of these three sizes will work. Now, what I want essentially is for this to also support a new type, which is like a tie-owned, which would not be a typer. And in fact, would be very small. It would be smaller than all the other ones. It would contain none of this body, almost none of this body. It would have a BST, or it wouldn't have a BST. Oh, wow. It would be quite challenging to implement, actually. I'm going to pause again while I think about this. Well, maybe not. Let's talk about this. So, this is where you get into possibility of over-optimization. Let's make sure I'm still recording. Yes, I am. You get into the possibility of over-optimizing things a little bit here. I have this fetch.gl, right, which I'd like to use for both variables. It's fetching globals, and for these new ownership things that I'm implementing. But these ownership things, let's just take a look at what the struct looks like here. Let's call it owned data. It's going to have some data. Let's call it owned value. It's going to have the value itself, which is what actually would be returned in the event that it was executed in Spore. Maybe before that it will have a type, right? So it's going to type. It has a value. This is kind of, so far it's very similar to tyvar. It's not in the BST though, so it's not part of a BST, so it doesn't need the BST. What else does it have? And it has these ownership things that we were just talking about. Ownership and declare ownership. I mean, it doesn't have declare ownership, but that's the, so converting this to C. Struct. Next. Meta. semicolons to offset to their S length. This is too big. We're going to keep those together. Okay. And this is called ownership. And so this will have one of those. Okay, so that's our struct. So this is a type, it has a value, and it has the ownership. Now, with the type, you can get a lot of the ownership stuff by default. Anything that's just a pointer to something that has its own ownership, its own declare ownership specified. I mean, you can call declare ownership on that, right? You don't have to rehash the ownership at all. The compiler can, the linker can freely call those types declare ownership. You only have to declare ownership on fields with the question mark, essentially, which are array fields with a question mark, unsized array fields, or a pointer, an unsized pointer. I think that gets lost. I think today that gets lost, whether it's an array type or a, because I have tie-I unsized. I don't have any information on array. I was kind of being a little tongue-in-cheek about that. I don't think I need it in the tie-I information, because that's the whole point of the declare ownership. All that matters is that it is an unsized type and you have to do something. Yes. That's one of the principles of Fngi, actually, is I don't try and solve all your problems for you. If you're making a dynamic type, you're going to have to do the right things. I'm going to, not let you use it incorrectly if you don't make a declare ownership function, but you could make a declare ownership function that does the wrong thing. I can't really control that because I don't have total control over your data. Okay, so this one's going a little slower here. But now I have this owned value. Let's see if we can add it to Spore. So I think this is probably part of the memory related things. Now, am I ever going to want to store? No. I think this is just getting pointers, and then you can operate on those pointers. So right now we have a literal. This is kind of a literal as well. Let's call it lito, which is an owned literal. And just like literals, it returns a literal, but it's an owned literal. Okay. Pointer. I think it's always a pointer. I can't think of a case where it would be anything but a pointer. So that's kind of the whole point. Haha. We'll call it. We'll just say how to get in. It's an and owned value. And actually, we're going to move the value first because just a minor optimization here. That way you don't have to do any point arithmetic. It's just a double dereference and spore. And the C compiler, whatever, should be able to do that very fast. Okay, so we have lit O. Let's take a look at what we do for lit. Oh, Fngi.c, lit. Yep, we have those are all lit. So we can accept, let's take a look. Let's just take a look over here. I don't really like doing this, not using the size stuff. 1.8. Global reference. Ooh. Local reference. Global reference. I like doing this. Owned reference. So let's get rid of that. Don't call it own OR though. We'll call it OWR. Case OWR. So we're going to pop a literal off. And this is literally just, we're just adding OV. I might be able to do this. I think this is pretty okay. Let's call this ref. So that would have been confusing. R0 is just a macro, by the way, for return 0. Didn't like that. Type. Okay, this all goes below type. Let's put it below all this stuff. Type dict. That's fine. Okay. Void. Right. Let's just make that S. It's not like. Okay. Okay. So what do we do here? We added a new command instruction called OWR, and I'm actually gonna move this up to the top, right? this up. Okay. We had a new instruction called OWR. That name.c, we're going to want to yeah. Is there special ones? No, that's all fine. But that's all fine. That's all fine. It's, I thought it was under gen. Source, is there debug? Okay, debug. Print trace. I have some method which does debug for us, and I forget where it is now. Pen? No. Thought it was in gen. Name? What's the instruction name? I don't know. I guess it'll break later. I thought I had it, but maybe I actually don't think I do. Sorry. I think I was thinking of adding it and decided against it. So yeah, getting back to what we've done. We added the OWR. We're adding it as an instruction. So planar cleanup, and then we can execute the instruction. We also added the and reference and the question mark so that we can specify pointers as being different size. A lot of minor little details here as we build out our language here. We also have the new ownership value here. We're not actually using it yet, but we have it. And yeah, we added the ownership constant in front of the little reference and the global reference. And we just quickly tested our and here. So let's groundwork for ownership. We might not actually use this for some time here. We'll have to see. Okay, so our next step was to maybe support this in our string. So right now our string is returning a literal and pipe. Right, we have this literal bit here, and the length is fine. We can push the length. That's just a value. But this pointer, instead of this lit here, I want to push an OWR. Right, that's what it was. OWR. So I think that requires us to allocate the OWR first, which we can do basically the same way as we are here. this gives us some nice code here for how this is done. We call XR on our allocator, which in this case the parse slice U1 has how we do that. It's the arena top. We're going to allocate. What are we going to allocate? Size of ownership. Ownership value, I think. Or owned value, I think. What was this called? Owned value. And this is R size. Alignment. Okay. And not only that, but we're going to have to allocate one ownership. Let's call it ship. This is going to be ownership allocation, and we'll assert that as well. Okay. So we got two things allocated there. Note that if it's immediate, we don't have to do any of this, which is nice. Okay, so now we're just going to construct these. Owned is going to equal dot type equals U1, and the ref dot ref equals s dot dot. Which looks good. I'm starting to think I should maybe make that let's just do that real quick. I think this should be a void value. We're going to cast the ref. Anyway, going back to this. Oh yeah, and then I don't have to cast this. The type equals that, and of course the ownership equals ship. Ship will equal ownership. No meta. We're not an array. Offset equals 0. That's the default, but we're going to set it anyway. And length, of course, is s.length. Okay. Now, this should just work because we're not actually doing anything yet. Forgot the beloved dot. Okay, we're not actually doing anything yet, so that would work. So we're going to delete this literal here, but we're going to op42, op2, op1. We'll add a new op4. Kind of surprised we don't have one. You know what? There's no point in doing that. The app. OWR. I think that's correct. We're going to add OWR, and then we're going to add for bnbn4. So we're going to add OWR, and then we're going to add our owned value. Don't need that. That is, I kind of thought this was the reference to this. Taiwan. That's not a reference. What's the problem? Initially, Thai dict. Oh. 2155. I think this can be a. I have a Thai, but I think a Thai dict is actually reasonable here. Pointer from an integer. Oops. This needs the B first. And that just worked. Oh no, it didn't. Test complete. Wow. That just worked. Let's just make sure we're actually calling our new code that we added here. Yep, there it is. Very nice. Where am I printing this? Debug working stack. Name, instruction name. Oh, that's just that. Okay. Okay. Add data.
Can we call Tanner? Can we call Tanner?
Okay, so that is pretty much it for ownership. That seems like it worked. We haven't really exercised it that much, but I think it's a reasonable structure. And I think that also closes out we can merge these. I or main. We're going to squash these. We don't need a separate groundwork commit here. So let's take a look here. We added our OWR instruction. We added and to our characters, which I always meant to have. It was an accident that it wasn't there. We allow specifying unsized pointers for later, mostly, but it's good to have it right now just to make sure it actually works with our infrastructure here, with our architecture. And instead of, we converted one line to about 5 here, which is unfortunate, but what this allows us to do is later our native compiler and our dead code analyzer will be able to actually know where data is that's owned by some instruction. So when it comes across an OWR, if it just came across a literal, a 4-byte literal, I mean, that could be a literal that the user wrote in their code, or that could be a literal that is actually a pointer to some data. And the dead code analyzer needs to know what data it is so that it can know what things it can and can't eliminate. Well, that's what this is. So this is an owned value. And it specifies what its offset is, which is just the field. The field is just the data field on the slice, so it's 0 because that's the first field. And it's the length. Now I'll probably eventually move this, some of this logic into the slice itself, but this is good enough for now. This gets us started here. It does it very explicitly. Eventually the type itself should implement declare ownership or whatever. We'll probably move this into Fngi. I think that would make sense. Yeah. But anyway, we're pushing an owned value. The ownership, eventually this will be removed, and this. These two things will be removed, but that's okay. And then we push it, and we also push the length, because that really is just a literal. And that's it. That is our code. Is our ownership data? Yep.